Hi everyone, hope you all doing well. So here in this video, we are going to analyze a multiple choice question from nuclear chemistry. So the question is the nuclear binding energy per nucleon of thallium with atomic number 81 with mass number 205 with atomic mass 204.9744 atomic mass units is. So the answer should be calculated with the units joules per nucleon. So we can see these kind of questions from nuclear chemistry in various chemistry examinations. So that's why it is very important to watch the video completely to get the detailed step-by-step analysis. Okay, right. Now, to calculate nuclear binding energy, we first determine the difference between the mass of nucleus and the mass of all protons and neutrons. Okay, so which gives us the mass defect. Then we can apply Einstein's mass relationship, that is delta E equals to delta M into C square. Okay, right. Now just look at the given nucleon, that is thallium 81 205. We know that 81 indicates number of protons and 205 indicates that is the mass number, and whereas so the difference between 205 and 81, that is mass number minus atomic number, which gives number of neutrons. So the total number of neutrons equals to 124. Okay, now the mass of 81 hydrogens should be equals to 81 into each hydrogen has the mass of 1.007825 atomic mass units, which equals to 81.63383 atomic mass units. Okay, right. And here we have 124 neutrons. Okay, 124 neutrons. So 124 into what is the mass of each neutron? That is 1.008665 atomic mass units, and you will get 125.07446 atomic mass units. Okay, now the predicted mass for 81 thallium 81 205 is the sum of these two, that is the sum of all the protons and neutrons, and which equals to 206.70829 atomic mass units. Okay, now we can calculate or determine the mass defect, that is delta M equals to what is the actual atomic mass of thallium, 204.9744 atomic mass units, minus what we have calculated, 206.70829 atomic mass units. Okay, so here you can get minus 1.7339 atomic mass units. So this is the mass defect we can calculate. Now we need to use Einstein's mass energy relationship. So that is here delta E equals to delta M into C square. Okay, so delta M, which we have calculated, just substitute here, minus 1.7339 atomic mass units into here C indicates the velocity of light, so 3 into 10 power 8 meter per second whole square. So here the result is minus 1.56 into 10 power 17 atomic mass units into meter square per second square. So here we have the answer in atomic mass units into meter square per second square. So here we need to convert the units into most familiar energy units. So they are joules. Okay, right. So recall 1 joule equals to 1 kg into meter square per second square. That's why here we need to convert atomic mass units into kgs. Okay, so delta E equals to minus 1.56 into 10 power 17 atomic mass units by into meter square by second square into here 1 gram by 6.0223 into 10 power 23 atomic mass units into 1 kg by 1000 grams. Okay, so by just converting the units from atomic mass units to kgs, you will get here minus 2.59 into 10 power minus 10 kg meter square by second square. So that equals to minus 2.59 into 10 power minus 10 joules. Okay, so here the question is here we need to look at closely because here the nuclear binding energy is 2.56 into 10 power minus 10 joules, but the nuclear binding energy per nuclear, that means for each of the nuclear we need to calculate. Okay, so here 2.59 into 10 power minus 10 joules by 205 nucleons. Okay, so that equals to 1.26 into 10 power minus 12 joule for nucleon. So the second option is the correct answer. If you like this video, please click on like and do subscribe for more updates. And if you are further interested, you can visit and join the website chemmasters.online, or you can download the mobile app Chemmasters from Google Play Stores, and you can join the best concept oriented online courses. Along with, you can practice very high standard online test series. Thank you very much.